Hi guys, I am Parampreet Singh, and in today's session we will mainly go through the complete ML workflow, basically like the complete machine learning pipeline, like from start to till end, from loading data till extracting features, and a little bit feature engineering, also some data analysis EDA. And then we will also we will plot some data, as well as after that we will do some, we will create at least two models in this and do some predictions. Okay, so yes, uh, this today's session will cover basically complete, no, not I can say like all the topics, or each and every function API discussed in week 2 of MLP, but yes, most of the main and important things will be covered today. Also, it will help for the MLP project, if you have MLP project this term, or in next term also, if you take so how to start the MLP project, how to create the notebooks and all. This session will help you and give you like a brief overview, uh, like how do you load the data, and what it, in each step what you have to do. Okay, so yes, let's start the session with this. Okay, um, okay, so can you all able to see this notebook?
Yes.
I'm just increasing the font size. I hope now it is very much clear. Not three, it's okay. So guys, just one thing, I want to keep this session as much as interactive as possible. Okay, I just don't like don't think, just say it's just a lecture I'm giving you all. No, I'm also your classmate as well, your college mate as well. I also have MLP and MLP project, so you can interrupt in between, and if you find I'm doing something weird or some wrong, you can also interrupt and correct me. Okay, I'm also learning ML side by side, but yes, I have a little bit more experience, so that's why I'm just sharing my learnings. Okay, so first of all, just you can speak, or raise hands, or give a thumbs up. I'll just ask 2 3 questions. Okay, first one, how many of you have MLP project? Okay, and now just second question, how many of you know about Jupyter notebooks and know the working of Jupyter notebooks? If anybody doesn't know about how Jupyter notebook works and all, they can give a thumbs down or any other emoji, so that I can like get to know. It's okay, if you don't know, but I'm here to help you, so that's why. Okay, so you all know about Jupyter notebook. Okay, two people. Okay. Uh, Now, uh, one last thing. How many of you know about Kaggle? Okay, so if you are attending my sessions, you might be, you know about Kaggle since the day one. Okay, so great. So we will start from the first basic thing, which is the Kaggle. Just give me a minute, okay? Okay, so first of all, uh, how many of you know about Google Colab? Just one last question, just to get the confirmation. Okay, so generally, when we code in Python, we mainly code in scripts, right? We create main.py, app.py, init.py, or something like that files in our local or in REPL or in anywhere, right? and there we code and run the whole script. Okay, so okay, but like uh, mainly in machine learning, not in machine learning, normally also, like when it is like there is another way of writing code, uh, not only in Python, like the Jupyter like there is another way of writing code in Python, which is using Jupyter notebooks. So Jupyter notebooks is just another way of writing the code, like not only the Python code, but it also supports various languages like Python, R, or also like if you use the Jupyter Lab, uh, it will like it has like it supports many languages. So Jupyter notebook and Jupyter lab, there is not much difference. Jupyter lab is like the complete whole environment of Jupyter notebooks, but a simple Jupyter notebook is like a normal notebook where you write the code and you get the output in like just below the code. Okay, what's the benefit of Jupyter notebook? Okay, before going into that, so like you can like there are various ways to use Jupyter notebook. One is to like create a local Jupyter notebook, and to like to run and to do so, you have to like there are like two ways, of course. First, in your code editor, you can do that by installing third-party extensions, like in VS Code also. If you are using VS Code or PyCharm or any other, there must have like they must have such, some extensions. In VS Code, like I have two extensions. Like there are two extensions which we use for Jupyter Notebook mainly. But like except Jupyter Notebook, like except sorry the code editors, you can download the Jupyter Notebook like you can work from the Jupyter Notebook in your local host as well. Okay, without any code editor. So like for that, you have mainly like two ways. One is using Jupyter Lab. You can download it, like install the Jupyter Lab, and yeah, installing Jupyter Lab or Jupyter Notebook, uh, you need pip mainly. Okay, so what is pip? Pip is like a package installer for Python packages. Okay, so you can either install Jupyter Lab or Jupyter Notebook. Jupyter Notebook is just one thing, and Lab is like comprises of the whole environment of Notebook. It also has some additional features. And to like run a Jupyter Notebook, what you can do is, okay, let me open it. Okay, let me open it here. So what you can do is, for using the Jupyter Notebook normally in localhost, I am like first open your command prompt or terminal wherever you want to save the Jupyter Notebook. Okay, then do this pip install Jupyter. Okay, let me just copy the command itself. So py Jupyter Notebook. Okay, so yeah, sorry, pip install Notebook. So you can just copy this command. Okay, and run it. It will install the Jupyter Notebook. So I have already have the Jupyter Notebook installed, so it is saying requirement already satisfied. After that, what you have to do is you just have to like type, I guess, let me, yeah, sorry, you just have to type Jupyter, okay, sorry, yeah, Jupyter space notebook in the terminal. Okay, after installing it, and hit enter. What it does is it will create a localhost server in which you can work in the Jupyter notebook. Okay, so this is one way of using the Jupyter notebook. Here you can see all my files in this current directory is listed here, and like the extension of the Jupyter notebook is .ipynb. So if I zoom in here, you can see like I have three Jupyter notebooks here as of now, ipynb with the extension ipynb. So if I like open it, like I just have to double click it, normally what you do. So here this is how it looks. Okay, and there are like various means of using Jupyter notebook. Like I told you, two ways. The third way is using Colab, like cloud environment, either Google Colab or like Kaggle. Okay, Kaggle notebook also like provide Kaggle also provide us a feature which is Kaggle notebooks where we can write the code. Okay, so I am using Kaggle, not the Google Colab, because it is like more efficient at it has like more basically memory and data support, so that's why as well as GPU and TPU also. So yes, like okay, now let's get into the benefit of what is the benefit of using Jupyter notebooks. So like normally if you have, let's say let's suppose you have 100 lines of code. Okay, so what you will do is you will write all the code normally in your Python file, and you have to run the complete Python file like by writing Python and my file name .py, right? So let's suppose you have various functions in your Python file, 5 6 functions, and like like 5 functions are working completely, but the sixth one you have just wrote, so you have to test it. So but when you run the Python file, so like all the functions will be executed, like all functions will run together, so it will take time, like it will consume more time. Okay, so here comes the benefit of Jupyter notebook. Let's suppose you have like some code which takes some, like let's say uh, some seconds to execute. I'm just giving a sample. So let's say if I write hello world here, okay, with the string s. So if I run this cell, so in Jupyter notebook we have mainly cells. We have two types of cell. One is code, one is markdown. Markdown is just for like uh, you can say documentation. Okay, for comments also. So markdown is a language also. So yes, markdown is mainly a language. So this is the code cell which I am running. What I have to do is I just have to like either click this play button, or I have to press shift and enter. So after this you can see it has like run successfully, and it is showing some cell number. You can ignore that number as of now. And like if you it works like the Python interpreter only. So like after executing this cell, if I just in the next cell if I write print s, it will work. Okay, so this is the benefit of Jupyter notebook. You can write multiple codes in multiple code blocks, and you can run each code block at once, and it will save it in the memory. Okay, till the you are running the Jupyter notebook, and once you like close it, it will also like save the output as well. So as you can see here, like in my notebook, you can see the output is also like saved here. I have not run this notebook, I have just opened it. So this is also the benefit. You can like save the output as well. And also you can export it in various ways, like let's say PDF. Okay, to export it, I guess from view, yeah, from file. So you can like export it in HTML, in latex, in markdown, in PDF, and in other ways also, in web PDF, and in slides format also. So yes, there are various ways of like reading a Jupyter notebook. Okay, so this is like just a brief overview about the Jupyter notebook. I hope now you all are clear. You can give a thumbs up, or you can speak up also. Okay. Okay, cool. So yeah, now let's start with the main topic of our today's session, which is like the complete ML workflow. So like I will be using competition dataset. Okay, so this is the competition New York City taxi trip duration. You can like check this competition from this link. I'm just pasting it here. Okay, just like one reminder, like I'll be like I'm recording this session, and I'll be uploading the recording of this session in my YouTube channel. Okay, I'll share the recording link also after the session, but like you can subscribe it and like just turn on the notification, so you will get notified whenever I will upload. Okay, yeah. So this is the like competition New York City taxi trip duration. Uh, like um, there are okay. So in Kaggle there are various things, like we can create our notebooks, like our code. We can participate in competitions. We can have data sets. We can also publish our data sets. We can also publish our models and use other people models as well. Also like we have code and discussion and other things also. So like there are various competitions held in Kaggle. So there is one type of competition which are called known as playgrounds. So playgrounds are like just for practice, like practice competitions you can say. Okay, so I am using one playground competition. This is like New York City taxi trip duration, and you can ignore like all the evaluation metric and all. Okay, as of now, because like in our MLP project competition we have just the basic accuracy as a metric. uh, so you can like join this competition as well. uh, like here you will get the option to join the competition. After you join, you will be able to see the like data and all. So like in here we have like data is like this data is very big. Like the train.csv, like they have uploaded the zip file here. I have extracted the files from it and it is of 200 MB. So yes, it is a very big data set. Okay, guys, just give me a minute. Let me get that. Okay. Yes. So where was I? Okay. So like this is very big data set. It is of like a lot of columns. Around it has like more than 1 lakh columns. So not the columns, sorry, the rows. Okay, so like regarding the competition overview, I have already provided like I have already given a brief like a very descriptive overview in the last session, so you can watch that session. Okay. And yeah, you can access the my session playlist also. You can save it. I'm adding my sessions here, so for the like if you want the competition overview, you can watch my this like session 3. Okay. So yes, uh, now like in today's session we will be using this competitions dataset, and we will do some ML, like end-to-end ML from starting till end, and then we will do some predictions also. We will also submit the predictions. As this is a playground competition, so there are like various types of competition. As I said, companies also like do the competitions, and like the best person, like whoever scores top in the leaderboard, they get some reward, or they may get some like kind of uh, placement offer or something like that. Okay. So it is up to the host of the competition. So it is a playground, so it doesn't have any kind of prizes. Now each competition has a leaderboard also. Yeah. Okay. So after that, like we can in the playground competition we can submit our code anytime, so I can submit it as a late submission also. Yeah. So let's start. Before that, like how many of you have completed the week 2 of MLP? Like if you have MLP. Okay. Guys, you can also speak up, नहीं तो मुझे ऐसा थोड़ा सा weird लगेगा कि मैं अकेला ही बोल रहा हूँ. So okay. So rest of you, I am assuming you have not completed week 2, right?
Yeah.
Okay. Uh, so in week 2 mainly like they have discussed about like some various APIs of sklearn, like the features, like all the things we have in sklearn. Okay. uh, yeah. So let me like just give you a overview of sklearn library. So sklearn, the original, like the complete name is scikit-learn. Scikit-learn is a library, like it is a machine learning library. So it has all the like important and useful things for like doing the machine learning and all the like data analysis stuff also, you can say. So like you can install it via pip, normally like pip install, yeah. So pip install scikit-learn. With this command you can install it in your PC or like in your computer. So after that, this is like the okay, this is the website of the scikit-learn. So yeah, sklearn docs. So if I open the sklearn docs, okay, back to it. So like it yeah, in tutorial we can see getting started. Okay, so sklearn has a lot of things. I'm not going into the brief of it. I'll just go on each go on like go one by one in the like while doing this. Okay, while doing the code. So as I said in my earlier sessions also, the docs are very useful. Okay, so you can use the documentation of sklearn if you get stuck anywhere. It is very like detailed. It also have examples. So if I like just search about let's say linear regression, linear regression, and linear regression example, I guess. Okay, not from here. Linear models, I guess. From here I'll get linear regression. Okay. Yeah, normally. Okay. So like it has very like brief examples also, like here you can see in each of their functionality and everything. Okay, so uh, okay, you can use this library of course. Okay, so let's now do the main thing. Like okay, let me, I have an image. Yeah, right. Can you all see this image? Let me copy it. Yeah. So this is like the main, you can say, machine learning pipeline or overview, you can say. Okay, the workflow of ML. So if I just uh, ML workflow, uh, um, ML workflow. So like the first thing in the ML workflow. Okay, so my voice is clear. Actually, my mic dropped. Is my
Yeah,
mic
it's
clear?
clear.
Okay. So like the first thing in like in the machine learning workflow is like data extraction here, as you can see. So data extraction, we already have the data, so we can ignore it. We can like just read the data. The second thing is data cleaning, like missing the missing values, uh, like imputing the missing values, like the null values or nan, you can say. Okay, so imputing them, and also like detecting the outliers, fixing the outliers, and also like doing the statistical analysis. After that we have like this data wrangling. So in data wrangling, what we do is mainly like modify our data, like okay, so generally we have only one data set, right? The like the train.csv and test.csv. But like in competitions or something like that. But when we like uh, do machine learning in real life, let's say we have to collect the data, so we will have various tables, or like if you are using SQL or something like that, we will have various tables and all of that. So we have to like basically reshape our data and transform it accordingly, which will work for the like ML models. Okay, then we have like this analysis part. Okay, so analysis is like analysis, and you can say data wrangling you can do interchangeably. Also like you can do this together. So in analysis we mainly do is EDA. So I have given a brief overview in last session about EDA. I'm not going into that. EDA is like doing the data analysis and finding the observations and all the things. Okay, also like in data wrangling we do a lot of things like feature engineering, or transformations to columns, and also like scaling, okay, feature scaling, and a lot of techniques are there. And after that, what we do is like we build the machine learning models. This is like the action part, you can say. We build the machine learning models, and we do the predictions, and hence like we either create APIs or something like that. Okay, if I yeah, okay, so let me go here. So let me like just write it once again. So first we have is like we have the data. We basically do the data cleaning, okay. Then we do the like mainly data analysis, you can say, EDA, okay. uh, and then like we do for like we ready our data for the machine learning, okay. So like data pre-processing, uh, pre-processing, okay. Sorry about the handwriting. I am using like this pen tablet after a long time. So after the data pre-processing, what we do is okay. Um, data, yes. Okay. Data pre-processing was in the cleaning itself. Yeah. After the ADA, what we do is like there are various things like feature engineering, feature scaling, and uh, like scaling or transformation, and a lot of things. After that, we prepare our model, okay. Then we evaluate our model. After that, what we do is we do predictions on test data, or you can say like wherever we want to do the predictions. Of course we won't end here, right? We mainly have to do the predictions that we are creating the ML model or doing the machine learning, okay. So this is like the main steps, you can say. um, all right, so let me like just open my one notebook where like I have all these steps mentioned um, clearly. Yeah, okay. So let me copy it here. So these are all the steps like ML workflow, you can say, okay. First step, obviously first step is here like in code. First step obviously is importing the required libraries and doing all the stuff. Then second is importing the data, and third is EDA, fourth is feature engineering, and fifth is feature scaling. You can like feature scaling and all those things. I have basically divided some important steps in, like I have divided some important steps, and the last is this submitting prediction. So yeah, I have like we will mainly do all these steps today, okay. Of course not in detail, as then the session will be very long, but yes, most of the things we will cover, okay. So अभी तक किसी को कोई डाउट? आई नो बहुत सारी थ्योरी हो गई, बट यस दिस इज लाइक some important thing. If you guys have any doubt, you can just like raise your hand or speak up. If you don't have, you can give a thumbs up. So like we can go ahead. Um, okay, Prabhat, do you have any doubt?
No, no, no.
Okay.
It was a fun thing.
Okay. So yes, uh, like I'll share the dataset and this notebook with you all. Okay. So I have imported this dataset here, New York City taxi trip. You can ignore this one. And I have three files here: sample submission, test.csv, and train.csv. Okay. uh, then like after importing the dataset, what I have to do is okay, let me drag it here. Yeah. I have to like basically this is like this just one step, one code block which Kaggle provides, which is just to give us all the path of the files we have, okay. So after it, okay, let's start with the first step, which is importing required libraries. So let me write it here. importing required libraries. And yeah, okay, before that, let me just give you an overview about our dataset. So uh, this is like a New York City taxi trip duration competition. In this, we have various columns, ID like for each taxi for each trip, and then the vendor ID, and then the pickup date time, drop date time, and then the passenger count, then pickup and drop latitude and longitude, and then we have this store and forward flag, and then we have last thing, which is trip duration. So this is the target variable. Okay, so in ML, okay, so like, let me get once. um yeah, so in ML, what we have is uh, okay, yeah, let me write it here. So generally, okay, yeah, uh, like uh, we have data, let's say like this. Okay, there are various columns, you can see, like these are all the various columns. Okay, so and in all these columns we have like we mainly split all these columns into two parts, which is one x and y. What is x and y here? So x is all the like features. Okay, like features of the, you can say, the data set which we are using. Okay, then we have y is our like target variable. Okay, uh, like you can call them as label also, feature, label, attributes, a lot of names are here. And the target label, or like predict not the predicted, okay, yeah, target label. Okay, so x and y we mainly have. So here, like in New York City taxi trip duration, we have all these features, these are all the features. And the last column, this is the y label. Okay, these are all in x and this is the y. So what we do is, we generally, like, we have, let's say, a model. We have a model, and we train our model basically, like, let's say I'm just writing it in a very pseudocode manner. So what we do is we train our model in based on these features, the x and this y. Okay, so we obviously have to pass this separately, so to mention our model, what is our target variable and what is our like are the features, are the basis of this target variable. So what we do is, like, in ML, behind the scenes, like you can say, there is all the mathematics which is happening, and mainly in mathematics, linear algebra. Okay, so linear algebra, also like a little bit of calculus for the optimization and all. So like you all have heard in MLP, like sorry, in MLT, like matrix manipulation, and like matrix multiplication, most of the things which is happening, and then like matrix or vector multiplication and a lot of. So okay, like before going into that, let me give you one example. So let's say we have a house price prediction data set. Okay, so like what we have to do, we have some data, and based on that data we have to predict the price of a house. So in like in like, let's say, okay, let me distribute the column. So y is our price. Okay, x is, let's say, size of house, number of bedrooms, we can say, and like balcony, we can say, like it does it has balcony, and does it has like a garden in here, and the terrace also, like there are various, a lot of things, also like parking. Okay, these are all the features, x. Okay, so based on these features we have to predict this column price. Okay, just a second. Yeah, so guys, is it like आपको clear हो रहा है ना? कोई confusion तो नहीं हो रही?
Yeah, it's clear.
Okay. So like based on these features we have to predict price. And like how do we do it? We obviously in behind the ML, like in the model training, the mathematics, the calculation is happening, the matrix multiplication and all of that stuff. So obviously it will all be in numbers. So first we have to make sure that all our data is like in numerical form, okay, and not in string or like categorical form, you can say. Okay, so I will be using a lot of technical notations in between. So अगर आपको कोई भी notation समझ नहीं आएगी, you can just speak up in between. Okay. Yeah, so we have to convert all these columns in numerical columns. Okay, after that what we do is okay, have you all heard about linear regression or something like that? um, okay, so three people have worked. Okay, so let's say let me plot a graph here. Okay, uh, in this graph what I do is I'll write here like in x-axis, and this is the y-axis. Y-axis I'll write the price, in x-axis I'll write the size of house. Okay, so like we have, like let's say if I plot the graph here, and this is like 100, 200 and so on and so forth. So if I plot like some values, I'm just doing a random scatter plot, you can say. Okay, so uh, this is like you can say these are all the points which I have plotted. Like for the 100, like if the size of the plot is 100, then the price of this house will be like here, whatever the value is here, this will be the price. Okay, so based on all this data, uh, there is a like very famous and very old algorithm, or like the base algorithm, you can say, for all the ML models, which is linear regression. Okay, uh, in ML we have two types of mainly like in supervised learning we have mainly two types of tasks. One is regression and one is classification. In regression we have to like compute um, okay, I forgot the term. uh, okay, okay, let me go from classification. So in classification we have to classify like something. So let's say if there is a picture and there is a cat in the picture, so you have to classify if there is a cat or dog. Okay, so this is the classification. Yeah, in classification we have uh, like the labels as, let's say, 0 1 or 1 2 and something like that. These are all the discrete values. Yeah, I got the notation. So these are all the, in classification we find the discrete values, but in regression we find the continuous values. Okay, so uh, for the price of a house, price is of course not price will be in a, price will be a continuous variable, right? So like it may be in float values also. So we'll like a basic algorithm is linear regression, which basically helps us to predict the continuous variable. Here the continuous variable is price. Okay, so to predict the price of a house, let's say based on this size only, only this size feature, the parameter, you can say, what we do is we plot a line. So let me have like some color if so we plot a line. Okay, the line can be like start from anywhere, obviously. uh, like let's say, okay, this is not a straight line. Do I have a line? Okay, so this is a line, you can see. Yeah. Okay, is anybody? Regression is predictive model. Yeah, real numbers, of course. Yeah, continuous variable and real numbers are the like same thing. So yes, we have in linear regression we have to plot a line. Okay, which basically like helps us to identify the relationship between the x and y uh, parameter. Okay, So like let's say based on this line, if I have some house which has like some this value, okay, let me use my a house which have, let's say, 350 size, okay. The size can be in anything, I am not going into the units, okay. 300 units we can say. So based on this line, what this model will do, this model will like simply, okay, my line is not that much straight, yeah. So based on this line, the our model will predict the price of this house, okay. So wherever the 350 is intercepting this regression line, it will intercept like the y-axis based on it, okay. So from here, so the price of the house which have size 350 will be something around here, okay. So this is what we have to uh, like mainly find the best fit line. So the line can be like of any shape, or you can say uh, and of any slope. Like currently the line is like this of 45 degree, but the line can be like this, or okay, I have to do it again and again. So line can be like this, or let's say like this, okay. So we have to identify the best fit line. So here, like the best fit line, if you can, if you see, is this, okay, this red one which I have plotted earlier, as like it is the best approximation you can see based on the data, okay. So we have to predict this line. And for like this line, generally like in linear equation, like if we do like as in mathematics we have like linear equation in one variable, right, where like we have some function x which gives us some value y, okay. uh, and the function x in like in the linear equation, the function x is of form mx plus b, right. This is the form of a linear equation, right. Are you all like, is this clear? Okay, yeah. So here m is the slope, right. This is the slope and b is the intercept. So don't worry, I'll go into the linear regression in detailed way in next session, of course. I'm just giving you a little bit overview. So we have to like in ml we, let's like change these terms to m and b to w, and just I'll just change the m to w, and rest I'll keep the same, okay, just like for the sake of notation. Yes, Nandan.
So do you need to know about math in MLP?
In MLP, like of course yes, I would not say no, because like they might ask you like you have this data and you have all these weights and you have to predict what will be the value using this model. Let's say SVM or linear
No, no, no.
regression
What
if you
I'm
are using.
do we need to know about formula, those things? We just need to know code.
Yes.
If it, know
Uh,
the process and code is fine, right?
uh, like during the coding, of course the coding the only the code is fine, but like in quizzes they will ask, okay, like they will just
Okay,
write the, like a model is in they have created a model, let's say linear regression, and these are the weights and the values, the data you have to
okay,
predict y. So you must know the formula of linear regression for this, right.
okay.
Yeah.
Thank you.
Okay, so like w here is the slope, okay. W also, like in machine learning we say it as weights, okay, weights or slope you can say. So like for a single, like here for the x, like we can just say it weight, not the weights. So हर एक लाइन का ना, like we have to predict the weight as well as this b. So mx plus b, here it is an intercept, but in ml we call it bias, okay. So bias is like okay, slope is okay, let me not go into the deep right now. So हमें ना weights और bias, हमें best weights और bias predict करने होते हैं, like to get the best best fitted line, okay, best हमें regression line ढूंढने के लिए. So अभी मैं आपको इतने बताऊंगा, rest I'll tell you after that. Like we have a lot of things, let's say, like uh, loss functions, optimization algorithms, gradient descent and all of things. ऑफ कोर्स उससे काफ़ी ओवरवेलम हो जाएगा, इसलिए अभी मैं उस पर नहीं जा रहा। अभी तक जितना मैंने आपको बताया, इज इट क्लियर?
Yes.
ओके, सो अब हम जो है थोड़ा सा लाइक ट्रांजिशन करते हैं टू द कोड। ओके, क्योंकि ऑफ कोर्स काफ़ी देर होगी। एंड यस, सो दिस इज़ द ऑल द कॉलम्स वी हैव, दीज आर द एक्स features, and this is my y label, which is the target variable. Okay, and I have loaded the dataset, so you can here you can see this is my dataset. So if I select all the columns, okay, rather like I'll just ignore it here. So yes, हमारा जो है इसमें like first step is in our ML workflow, import required libraries. So we will mainly be required three libraries as of now. First is NumPy, second is pandas as pd, third we will be using like scikit-learn. For scikit-learn I will do like the import later. Okay, then second step is import the data. Okay, so let me write it here. Second step is import data, and data, like here you can ignore last three lines. Okay, so these are all the three files we have. So sample submission will ignore, just like let's just ignore right now. We mainly have these two files. Okay, first is train.csv and second is chess.csv. So मैं आपको थोड़ा थोड़ा ओवरव्यू दे दूंगा about like both of this, what is the test.csv and what is train.csv. I'm just loading it right now. Okay, so train.csv को मैं df में load कर रहा हूँ, and in the like the test.csv I'm loading in test_df. Okay, so I am loading this dataset as of now. So if we read the dataset, if we see the head, so these are all the like uh, this is the data. Okay, which we can see, this is the id, this is the vendor id, and here it is the pickup date time, drop off date time, passenger count, pickup longitude, uh, latitude, drop off longitude, latitude, and then store and forward flag, and then trip duration. We have to mainly predict this trip duration. Okay, so whenever we load a data set, जब भी आप like say जो whomsoever like have MLP project, आपको स्टेप सेम ही करने हैं. ओके, just that the data will be different, so accordingly approach will be different a little bit. Here like we are using this we are solving a regression problem, because the duration, this duration is in I guess minutes, or you can say okay, so yes, uh, this duration is here. So of course this is the like regression task, and I will try कि मैं कोई और data set ले पाऊँ which is of classification. I'm just like using this like for the sake of this date time columns, mainly because we have date time columns in MLP project, so it will help you do the analysis and the feature engineering mainly. So this is like the data which we can see here as of now. After like reading the data, what we do is EDA. Okay, the third step is EDA. So let me like just write it here, EDA. So in EDA we mainly look into the data in more brief. Okay, so I'll do df.info. So with the help of info I can see all the columns. So here all the columns are like these are the columns. I have total 11 columns, and all having like none of them having null values. So yes, this is very like you can say prepared data set. I'll find a data set which is more useful. Okay, for the next session. Rest, like you can see, we have 4 float columns, 3 integer and 4 object columns. And okay, we have, as you can see here, like we have all these like id here. So like this is the id of each trip. Okay, a unique identifier, so we can treat it as the index also, right? So what I'll do is, let me just write the uh, one line here which is index column, and let me use this id column as index. Okay, Same I am doing for the test.csv. Okay, so let me load it again. Now if I run it, you can see id is now little bit down here, it's just representing the index, not the column. Okay, and these are all
What
the
about
columns we have.
zero? Uh, Sorry to interrupt.
Yes,
What about normal index?
normal index will be overwritten by this id column, as I have
Then
specified
what?
here.
What if we want to do like iloc?
Iloc we can do. Iloc, as the name says, iloc, it is integer location, you can say. Okay, so it is using the
So it doesn't matter what index we are using, right?
right. For the iloc it doesn't matter, but for the log it matters. So let's say if I
Okay,
want the
okay.
first row. Okay, so I'll just write 0, so I'll get the first row here. Okay, with the help of iloc. But if I write a log, then I'll get the error, key error, because this is not in the like index. Like here you can see this is my first row, right? So if I copy the id from here and if I write it here in the log, of course it is in like id something, so I have to write it in strings. Then if I run it, you can see I get the same data.
Okay.
So this is the difference in iloc and log. Okay, in iloc you use integer based indexing, but in log you use normally. Is describe command enough for ada? No, it is not enough. It is just the first step. ada is a lot. Like jitne bhi you do the data analysis, it will be less. Yes, of course you have to prepare like histograms and a lot of things to get to know about the distribution and outliers and a lot. Okay, so this is it. Okay, so I think uh, let me Kaggle.com competitions playground. um, um, still okay, I have this Titanic data set also, not the Titanic classification. I'm like just finding a classification data set if I'll get a better data set. So uh, you have to predict the probability of the target label. Okay, this is multi-class classification of obesity risk. We have, okay, if I just normally go to, okay, Titanic, this or this, let's use this one, data, or Titanic machine learning from disaster, and like let's may find, okay, I'll leave it as of now. I'll find a suitable data set after the session, that will be better. So like we have okay, we were doing the ADA, right? So first one is like to look into the columns, what are the types of columns we have and how many columns do we have. Then this is just a sample data, and then like the third thing which we generally do is describe. So we describe do is takes all the numerical columns and do some like descriptive analysis, like the count, the mean, standard deviation, minimum, 25th percentile, 50th percentile, 75th percentile, and the maximum value of each of the column. Okay, so yes, this is all the which you can see. Of course, like in EDA we also do the plots. Okay, so for the plots I'll use matplotlib library, matplotlib.pyplot as plt. So I'm using the matplotlib library as plt. Okay, and I'm using a magic command here. So in Jupyter notebook we have various kinds of magic commands, special commands you can say. So this will help me like to plot the graphs in the output area itself. Okay, so that's why I'm doing this. I'll just run this cell again. Then okay, so normally like value error. Okay, Yeah, so okay, first let's get all the numerical columns. Okay, so there is a like function uh, in pandas, like in a data frame, which is called select data types. Okay, in select data types, if I like uh, if I just run the select data types, it will obvious okay, yeah. So in select d types, what we can do is we can select the columns of some different data types. Okay, so let's say if I want all the numerical columns, what I can do is I can just write include, and I have to pass a list, like and in the list I'll just write int. Okay, so if I do this, I'll get all the integer columns. Okay, so yeah, so I am getting all the integer columns. So like here you can see the longitude and latitude are in like they are in floats, right, not in the integer values. So if I write in here like float also, okay, then I'll get all these columns. Or I can also do like if I know there are only, like here you can see we have only three types of columns, which is float, int and object. What I can do is I can exclude the object column. How can I do this? I'll remove this and write exclude, and in this I'll pass a list and write it object. So it will exclude all the object columns and give me rest of the like data, and with the help of dot columns parameter I'll get all the columns. So these are all the integer and you can say float columns. Then I'll just write I'll just assign it to num columns variable. Okay, so these are all the numerical columns which I got. Then there is a function. Okay, uh, then there is a function of data frame which is called core. Okay, so this basically finds the correlation of each column. Okay, so here you can see it has finded the correlation. So correlation is generally it by default use the Pearson correlation. In statistics 1 you must have like read about the correlation. Okay, so there are various ways of finding the correlation. So in Pearson correlation we have the values between -1 and 1. Okay, so to the same columns we obviously have the correlation as 1. So vendor id to vendor id it is 1, passenger count to passenger count it is 1. So that means all the diagonal values are 1, and for the rest we can see the correlation here. But normally, like rather than checking it numerically, what we can do is we can plot it. How? uh, okay, like let me use the Seaborn library that has like uh, function for like plotting this, which is a heat map. So I'm using the Seaborn library as SNS. Okay, let me run the cell again so it will get imported. Now what I'll do is I'll just write SNS dot heat map. So heat map is a type of graph. Like okay, so have you like heard about GitHub? How many of you know about GitHub? Okay, so like in GitHub if you go and see, um, we have okay this kind of graph. Okay, so here this graph is a heat map. Okay, so it basically shows us number of contributions done in a day. So those which are like uh, which are very bright color, very bright boxes, they shows like I have done more contributions and compared to the lighter one. So here like you can see I have done only one contribution on February 26th, but on the like 20th May I have done 18 contributions. So this is the heat map. Okay, similar heat map we will generate here like for our data. What I'll do is I'll just take this correlation data and paste it in the heat map, and I'll just run it. So here you can see this is the heat map. Okay, uh, like there are various color mapping also like for the heat map. I'll not go into that. So what this indicates is there is this is the scale. I'll also write and not equals to. So this basically shows us the values also. Okay, so here right here you can see these values. So this is on right hand side you can see this scale, the scale is from 0.0 to 1. Okay, so below that obviously the correlation is from -1 to 1, so below that of course the values will be more darker. So we mainly have to check the correlation uh, like of all the columns related to like our target variable, okay, which is the trip duration. So let's just look into the last row, which is this trip duration, and here you can see the vendor id is correlated, like it is slightly correlated, okay, and also like it identifies the linear relationship, not like any other relationship. So there are various ways to like find non-linear relationships. I'll like tell you more about that when we do more EDA, okay. So vendor id is slightly less correlated, and the passenger count you can see it is like way less correlated compared to the vendor id, so as the value is very less, okay. And this is the pickup longitude, it is a little bit better correlated. And then there is pickup latitude, it is negatively correlated. So negatively correlated, by this means you can say that okay, if I just go here, if I like plot something here, so this is, let's say, my x and this is my y. So if the line like if the correlation line is like I have plotted some data, you can ignore like if there is some data. So if the line is going like this, okay, you can say this is positively correlated. If the line is like going like this, like the slope is downward, okay, like the slope is going down as the value of x is increasing, so this is negatively correlated, okay. So this is like you can say about the correlation. So the latitude is negatively correlated and the drop of longitude is positively correlated, and same for this. And of course trip duration is positively highly correlated with this the say itself, okay. So this is like a basic thing we have done. Okay, so like yeah, now let's say let's check yeah, passenger count. So let's check the passenger count uh, column, and let's see all this the values it has. So I'll do the value counts to check the distribution. Value counts. So here you can see the passenger count, like the 1 2 5 3 6 4. So like most of the passengers like most of the trips have only one passenger, then there are few which has two, then there are some which has five also, and there is one trip which has zero passenger. So this is something weird, right? Like if some taxi like do some kind of trip, then it must have at least one passenger, but it has zero passengers, so you can like call it as a anomaly. So there are anomalies in data. What do you mean by anomaly? Like generally, okay, for the anomaly let me explain it like okay, let's say I have this, okay, so this is my plot, okay. So generally, like let's say the data is going like this, okay, like as the value of x is increasing, the value of y is also increasing, okay. Here what will be the anomaly? Let's say for some value of x, some lower value of x, the value of y is very high, okay. So this is called as anomaly, okay, which is some a thing you can say which is not normal. Obviously for a taxi trip, if there are zero passengers, then what is this, like what is the trip meant to be? So this is kind of an anomaly you can say in data. And this anomaly, if we have like multiple anomalies in data, then this can obviously lead can affect our model also, okay. So outlier, of course you can also say outlier. Anomaly also is another word, and like there is some slight difference in anomaly and outlier, but of course like you can use these terms interchangeably also. So let's plot this data to like get to know about the distribution more. So what I'll do is I'll just copy the same command and I'll just write the dot plot here. We have a function in pandas like for series and data frame, which is the plot, which will basically plot the data. So here you can see the data is plotted in a linear chart. This is a line chart, obviously it's not much readable. So what I'll do is I'll write kind and write bar, so it will plot a bar chart for me. Now here this is more readable compared to the line chart, right? And here you can see most of the passengers, like most of the trips which are done have one passenger, and then we have 2, then 5, then 3, then 6, then 4, and then for 0 also we have one. So like for 0 here, this is the anomaly you can say, and this is also like come as a outlier. So like as you have said outlier, so outliers are like which are like above some threshold, like above some quartile of like data. Okay, so one is also like you can consider it as outlier because this is way much like our data is okay, it is left skewed if I'm not wrong with the term. So data is very left skewed, like most of the passengers, like most of the trips have done with the one passenger only, and there are few which are done with the 2, 5, 3 and 6 and 4. So this is like a simple plot which we have done. By this, like by doing all this data analysis, we'll get to know about our distribution, and we can also fix our data. Like we can fix the outliers, we can fix the anomalies. I'll use like various data set in different sessions, so जिससे आपको और भी अच्छे से पता चल पाए. Okay, like how to do the data analysis better, in a better manner. Then we have like another column called vendor ID. So let's just check about this vendor ID dl vendor ID dot value counts. This is the last part which I am doing in ADM. Okay, so this is the vendor ID. So there, like you can say there are only two vendors for the taxi trip. So vendor in a taxi trip you can say like the service providers. Okay, like in India we mainly have two, Ola and Uber, right? So these are, there are only two vendors. So we can also plot this to see like the distribution, obviously by numbers also we can see. And there is one parameter called normalize, which will show us the ratio. Okay, the same ratio we can see with the help of pie chart. So what I'll do is I'll just do the plot and I'll write in kind pi. So it will show me the distribution. So this is the distribution of the vendor ID. So here you can see the vendor 2 has done more trips, like the taxi from the vendor 2 has done more trips compared to the one. With the distribution also you can see, so there is a like, this is not the 50-50 equally distributed, but yes, there is, this is the distribution you can say. Okay, so abhi tak, like is it clear to you all? Like what we are mainly doing is we are basically analyzing the data, we are analyzing the columns and all. Then like we have some other columns like these latitude and longitude. This like for this we can do a lot of feature engineering, of course, for the datetime columns as well. Okay, oh yes, let me include the datetime column too. Okay, so like if you remember in the last session I discussed some like things, some functions to use datetime columns. Okay, so what I'll do is while creating the data, I'll use this parameter parse states and I'll write these two column names which are which represents the dates. Okay, so the first one is this pickup date time and the second is drop off date time. So I'm just passing a list of the columns which are of the date time type. Okay, so it will be interpreted as a date time. Now if I run it, okay, I am getting an error which is saying uh, parse, okay, test, okay, test.csv. So let me check the test.csv once. before doing this. Yeah. So for our main data frame we have done this, the test.df. We have pickup date time. Okay, so we don't have the drop of date time. Of course, the drop of date time, if we have the pickup and drop off, then we can easily predict the duration, right? So we also need to get rid of this column, right? So okay, let me just drop it off here only. So drop columns. Yeah, now it will work better. Now okay, yeah. So now if I run this df.info, here you can see I am having this column, like the pickup date time as date time column. Now here also you can see all the unique columns. I have one column which is of date time type. Okay, so like as the time is already 7:30, so let's move on to like other steps. Now what we will do is we will do some feature engineering. We won't do the feature scaling today, but yes, we will do the feature engineering. So let me just copy it. um, Here we don't need any kind of data pre-processing as of now. मैं धीरे धीरे I am just going. Okay, जैसे जैसे like we will do more sessions, हम और भी deep में and in brief we will see about like all this. Okay, like handling outliers, handling missing values, and a lot of things. Okay, so let's write here fourth feature engineering. uh, Now let me just look into my data once. So this is my data. Okay, okay guys, अभी तक सबको clear है? uh, okay, cool.
Yes, yes.
So now in the feature engineering, like you can see we have this pickup date time column and then passenger count and a lot of things. Okay, uh, now generally mere yeah, for before doing the feature engineering, what we have to do is we have to split the data into like the x features and then the y column. Why? Because obviously हम feature engineering हमारे target variable पे तो नहीं करेंगे, right? So we have to separate out our columns. So what I'll write is I'll write x equals, then I'll write, there are various ways, uh, like using ilog also, using log also. I'll just do a normal way, which is like the not the drop any, yeah, drop. I'll write columns here and I'll pass a list which says trip duration. So in x I'll have all the columns excluding the last column. I can also do it in another way, I'll show it to you. Then I'll select the column here in y. Okay, if I run it, so let me take this cell up. Yeah, if I now run this x dot head, you can see, and if I run y dot head, you can see this. In the in x now I have all the columns except the last one, which is trip duration. Okay, and in y we have only this trip duration column. Now this is only one column, so obviously by default it is a series, not a data frame. Obviously we can convert it, but we don't need it. We don't need to convert it. Yeah. So now what we will do is, okay, anybody of you know about any other way to do the same thing? I'm just like curious. Can you all tell me some any other way?
Can we select multiple columns inside a list?
Okay. So like this vendor ID, right? You are saying.
Yeah.
But let's say if we have a lot of columns, let's say 10, 20, 30 columns, then we have to write name of each of the column. Do you have a
We
better
can
way?
use, yeah, we can use ilog,
Okay. I log, then
then zero semicolon,
0,
semicolon,
Semicolon or colon?
comma, yeah, colon,
Okay, zero colon, then comma,
then colon.
then colon. Okay, is this it? Or like, do I have to do any kind of changes? Um,
I I think ending will it will only have column name, right?
and ending. Okay, आप बताओ.
I mean I mean it will only have column name, right? So we can change index of starting index. Yeah,
Okay, so this is ilog. Okay, so in ilog we only have integer indexing. Okay, first of all, just to clarify, so we can't use any kind of like column name or something like that. Even for the columns, if we have to select, we have to use indexes like 0 1 2 and so on. Okay, सो जैसा आपने बोला, इफ़ आई रन दिस नॉर्मली, तो मेरे पास x जो है पूरा का पूरा सेम एज जी एफ मिल जाएगा. वाई? बिकॉज आई एम सेलेक्टिंग ऑल द रोज. डजेंट मैटर इफ आई यूज जीरो हेयर और नॉट, बाय डिफॉल्ट इट विल सेलेक्ट फ्रॉम द स्टार्टिंग रो. ओके, and then I am selecting all the columns, but I don't want to select the last column. What I can do is I can write -1 here,
-1.
right?
Yeah,
So it will exclude
right.
the last column, and now if I run it, you can see I get this same thing. Now there is like another way. Obviously there can be a lot of ways. So another way is this, df.log. First of all, I'll select all the rows with the help of colon. Then I'll select all the columns except the last column, which is trip underscore duration. Here we will write the column name because we are using log, not the ilog. Okay, now if I run it, and yeah, now it ran, and here you can see, okay, okay, so in the log I have to specify till the columns we want, so I'll use this, not the trip duration. Now if I run it, here you can see I'm getting the same data as we needed, right? So these are the
Right.
three ways of doing the same thing. Of course in pandas we have like a lot of ways to do the same thing. You just have to use whichever suits you, and of course like if we have a huge amount of data and we are doing a lot of pre-processing stuff, then we must use the efficient way. So iloc is very efficient compared to this because we are like dropping the column and uh, like getting a new data set, uh, and in log we basically iterate over all the columns, but ilog is way more efficient because it is using integer based indexing. Like the implementation of ilog is efficient, so that's why it is considered to use. Generally people uses ilog compared to both of these ways. Of course there will be some more ways also. So this is my x dot head and this is my y dot head. So now in the feature engineering what we do is we either like we have a lot of things to do feature engineering. Like we transform the features. By transforming I mean like, let's say squaring the features, or like finding the like squaring out, or like transform. Let's say we have like the size of house in uh, like the let's say the size of house in like square units, and the square units is very big, so we can transform it into log of square units. Okay, so the log is better compared to the normal units. And transform features, we can create the features, we can drop some features also, but that comes in like the data pre-processing, not in the feature engineering. Of course we can drop the features, like we can exclude or remove features based on the created features, and these are like the main things which we generally do in feature engineering. Okay, here also like I have written like make multiple features and check correlation. You can ignore the detailed stuff, but as of now just let's focus on this. So we won't be like uh, doing this all this. I'll just show you one thing, like I'll just create some new features. Okay, so let's create some features. So dataset जैसा, like as you can see, we have this pickup date time and this passenger count. In passenger count we don't have any much more information we can extract, but like if you see the pickup date time, if I plot like not use the df, if I use this and let's say if I use value counts, so pickup date time we have like 79,742 values. So these are all the different dates, okay, dates and times. Obviously in same day we can also have multiple trips. सो आप देख सकते हो दिस इज़ द कंप्लीट डेट टाइम. हम इससे टाइम भी एक्सट्रैक्ट कर सकते हैं एंड डेट अलग एक्सट्रैक्ट कर सकते हैं, राइट. सो दिस इज़ लाइक वी कैन हैव टू फीचर्स फ्रॉम दिस फीचर ओनली. हाउ? what I'll do is I'll just write .dt then .date, then I'll get the date only, okay. And similarly if I write .dt then .time, I guess, yeah, so I'll get the time. So here you can see like मैंने time और date extract कर लिए. Now I have to create two columns based on this extracted features, okay. So this is called as feature extraction. Mainly it comes under feature engineering category, okay. So let me write a note here, like just for the clarification purposes, like extracting date and time from pickup date time. Don't worry about the backticks and all, I'm just writing it for the sake of formatting, okay. So let's extract these two features. Okay, to create a new feature we just have to write the feature name. Let's say let's write pickup date, okay, then pickup date, and then what we will do is we'll just copy this line, and same thing we should do like for the test data also, okay. Of course आप टेस्ट डेटा को एक बार ही देख सकते हो, बट लाइक लेट मी जस्ट चेक द टेस्ट डेटा. So test data is of same format as of this, so I'll just copy this line and do the same stuff for the test data. So I'm just replacing the x to the test data, okay, test underscore df, and let me run it. Now this is run successfully. If I do x dot head, here you can see I have a new column named pickup date, and इसमें सिर्फ dates हैं, we don't have the time here. Similarly we can do the time one also, right. I'm just replacing the date with the time here, and the name of the column also, pickup time and pickup time, okay. Now if I check my this, so I have now two more new columns, okay. So this is called feature engineering. हम different columns बना सकते हैं, lot of things we can do. Of course now also if you see like this, generally if I like do this, अगर आप इसको देखोगे, so we have year here, like we have multiple years here, and then multiple months also, like this is the month and this is the date. We have multiple dates, we have month, and we have a lot of things. So if I do dt dot year pickup date, okay, so let's check the value of it once. X dot info, is it of, okay, it's of object. Let me translate into the date time. How can I do that? I can write pd dot to date time, then I'll just pass it here. So the same thing, let me, okay, the same thing let's do here. Instead of x, the test df, and the same thing let me do here, pd dot to date time, and here also let's do the same thing, pd dot to date time. Okay, not convertible to okay, pd dot time delta. Yeah, sorry for the time, I have to use the time delta, not the date time. Yeah, right. So let me run this cell again. To date time, it's not the date time. Yeah, so अभी भी जो the format of the dates is same. Okay, here also, okay, I'm getting some another error which is invalid type for class, invalid type for time data time delta scalar. Okay guys, just give me a second. Okay, so uh, here we have invalid type for time delta scalar. Okay, so let me just copy this error once and check it in Google what this is saying, how to ask. Okay, so I have to convert it to string. If I do as type string, uh, it is not able to like uh, uh, it is not able to interpret what is this, like what the type of this object, what is the object we have. Okay, so I'm just converting into string, so then it will work. Yeah, so now it works. Here you can see I have this pickup date, pickup time. Okay, now if I do x.info, we have this date time object, and now we also have another kind of object which is time delta. Okay, now uh, we have all these things. Now let's come to the like the main part, which is the scikit-learn library, and the main thing also for the our machine learning workflow. Abhi, like we have columns in like various data types. Here you can see, right? In int, date, time, int, float, object, date, time, time delta. So what we have to do is like we mainly have to convert these columns like to the numerical columns, which will help us mainly for like the training of the model. Okay, so how do we do it? We have this. Now let's use the scikit-learn library for this. Obviously we can do with manually also, like with the help of pandas library, but like I am using the scikit-learn library for like for the sake of easiness, and we have less time right now. So in scikit-learn library, what I'll do is I'll write uh, yeah, pre-processing, sklearn dot pre-processing, and I will do here, which is okay. I think, okay, I guess I forgot maybe. Yeah, okay, not, yeah, ordinal is here, no? Okay, what I have just done. Oh, my, it is loading. Just a second. So yeah, now in sklearn.preprocessing we will use ordinal encoder. I'll tell you what this is. Okay, don't worry about this. What is the syntax error here? Dot
Capital
preprocess.
O, I think.
Sorry, what?
Capital O.
This is a capital U. Okay, let me write it once again. Sklearn dot preprocessing,
Import. You
import
have.
ordinal encoder.
It will be import.
Oh yeah, yeah, sorry, import. Okay, oh no, it is not the import, it is
Oh,
from
yeah,
sklearn
it's
dot.
from.
Yeah, sorry, my bad. Yeah, so this is like ordinal encoder. What it is, let me just like give you a simple overview about it. So let's say we have a column, uh, like okay, here we have this column. Okay, we have this column, a store and forward flag, and if I check the values of this, um, df value counts, we have yes and no. Okay, so we have yes and no here. What generally this ordinal encoder do is, it basically helps us to transform our categorical columns into numerical columns. So what are like categorical columns? Those columns which can be divided into some category, not in the uh, not in numeric, which are not included in numerical columns. Those are categorical columns, you can say, uh, like which are being categorized, you can say, based on like here we have yes and no, and we also have like created two more columns, which are these, pickup date and pickup time and all. Okay, so these are all the categorical columns. So what uh, this ordinal encoder do is, so okay, I forgot the name, store and forward flag, I'll just use the name flag. Okay, so in flag we have these two values, y and n. Okay, so ordinal encoder क्या करता है, it maps these values to like integers. So we have only two values, so it uses like from 0 to 1, like from 0 it will start, and to the how many distinct value we have, it will map based on this. So here like we have only two values, so what it does is, it will map all the yes to 0 and then no to 1. Okay, so of course we can do with the help of some pandas functions also, uh, but let's just like right now, let's use only this ordinal encoder, so आपको थोड़ा स्केलन का भी पता चल जाए. Okay, so what I'll do is, I'll create my encoder first. This is the way to use ordinal encoder. Okay, I'll write ordinal encoder, and then in the ordinal encoder, I'll just write encoder dot fit underscore transform, and here I have to pass the data. Okay, uh, like I have to pass the data, of course. Then what should I do? Like first I have to select all the columns which I have to encode. So except all the integer and float columns, we have to encode all these columns, like the object and the date time as well. So what I'll do is, I'll select all the categorical columns, let's say here, and I'll use x dot select d types, what I used earlier, and I'll exclude the int and float. Then if I write cat calls, here you can see I got these categorical columns. Then I can just simply write x and cat calls, and if I run this fit underscore transform, okay, boolean array expected for the condition, not date time. Okay, it is not able to encode the date time object, so I'll just like, let's, for the sake of this basically current model, we do not parse the date time. Okay, so I'll just ignore from here, dfed, then passenger count, and I am just running all the columns again, all the cells basically. Okay, so yeah, what I can do is, pd dot to date time. Yes, now I have this. This is my test data. Yeah. And I'll just convert it to string. Okay, rather than the date time, because obviously there are ways to do this, like to encode the date time columns, but right now I'm just preparing a basic model. So what I'll do is I'll just encode it normally. So we have this, and now yeah, I don't need to do this. I think I can ignore this step. Okay, I need pd.to date time, then pd.to date time, and here test here. Yeah. So now if I run x.head, I have this, and I have all the like object columns and integer and float columns. What I can do is either I use exclude and I can use include and write object here, then I'll get all the categorical columns. So these are the categorical columns which I have to encode. Okay, so there are many ways like label encoder, ordinal encoder. There is a little bit difference in label and ordinal encoder and one hot encoder. I'll tell you like different ways in the next session. Okay, uh, now like I'm just using the ordinal encoder here, and I'm transforming all the categorical columns. Okay, still I'm getting the error. uh, Boolean array expected, not okay, no problem. Okay, I did it here. I think I am doing some mistake. For transform I'm just using, okay, ordinal encoders. Okay, got it. I guess I am, yeah, I have this category. I have to convert it to columns. I have to use the columns only. So these are all the columns which I have, object columns. Now I am just using the fit transform, and if I run it, here you can see now all these columns are like transformed into numerical values. Okay, so these are the like numerical values. Obviously, like for the date time we have uh, various values, so that's why like it has a lot of different distribution, you can say. And for this we have only just 0 and 1 and so on. So let me like convert it into np.int, let's say 16. Okay, not 16, it has negative values. uh, okay, not 31, 32. Yeah, so here you can see all these values are now encoded, okay, into the numerical values from the categorical values. Like here if you see, these are, okay, let me use this x cat calls dot head. So these are my categorical values, and these are now converted to the numerical values. Of course, by default the encoders gives us a matrix like the array. It does not gives us like the data frame itself. We have to convert it into the data frame. Now there, like in encoder we have two functions, which is fit transform, and another we have is transform. Okay, so what does fit transform do is, fit transform basically maps all the values, and the transform function will like convert the values based on the mapped values. Okay, I can either use like normally the fit and then the transform, or I can use the fit transform, like, okay. So there are three functions, xcat calls, and okay, so let me, yeah, I can either use this way, okay, normally, or I can use only this second line, this one. So both will do the like same thing. Okay, then for the test data I have to use this thing transform, not the fit transform, because the data is already fitted to the like ordinal encoder, so I don't have to do all the mapping again. So it is basically calculating the mapping and all the stuff, the fit function which is doing here, which is this, and then the transform is here. Now it returns a matrix, not the like it returns a matrix, not the data frame. So we have to convert this to a data frame. What we do is, okay, uh, let's ignore the
Can you
test.
Can you explain again why we don't use fit transform?
Okay, so okay, earlier we have this. Yeah, so normally what we do is we have these two functions, which is fit and then transform. What fit do is fit basically calculate the mappings, like for the yes whether it will be 0 or 1. Okay, so like normal, it is a normal calculation. It does like there isn't any special algorithm for it. So basically it just like we have fitted the data. Okay, so based on the mapped values, like it will create a dictionary, let's say, which will map, let's say, no to 0 and yes to 1. Okay, then the same thing if we do, then we have to transform the data. If I normally run this cell, then I'll just get the my ordinal encoder. uh, then to transform these values, I have to use this transform function. So I'm like doing the same thing, the fit and the transform, based on the same data, like on my x. Okay, so what I can do is, I can, rather than this, I can simply use fit underscore transform, which basically calls both the functions together. Okay,
Okay, okay, yes.
yeah, so I am doing this. Now for the test data, of course I have to use the transform, because I have already fitted the data in it. Now uh, what I'll do is, this is giving me a matrix, like, or you can say array. So I have to convert it into a data frame. What I'll do is, I'll write here pd.data frame, and this is my data frame. Now these data frame don't have the column names, so I'll provide them the column names which we have earlier, which are the cat calls. Okay, these are the columns. Okay, because the column names are same. And I'll also provide the index, same as the index we have for the x. So now you can see, like, the index, we have the same index, and we have the same column names. So now I'll just assign this to my, like, here, I'll write x cat calls equals to this pd dot data frame. And I am doing this stuff. If I just like write it in some new lines, so I have this, like, I have transformed the data into numerical values and converting into the integer 32. Okay, like, for the sake of uh, readable format. Okay, so after that, like, I am assigning the column names. The columns are same, we have not created any new column, so I am just providing the same column names, which will basically override to this. Okay, so right now we have this data. Okay, and I'll also do this x head. Here you can see I currently have these values for the, like, pickup date type, and all the three columns here. But when I run this line of code, this code block, then my columns will be transformed into the numerical columns, which are these. And the same thing I will do for the test data. Okay, how I'll just write the test gf. The categorical columns will be the same, and I'll just replace the x with the test gf. Just that's it. I don't have to do any of the other thing. Also, one last thing, which is, like, I have to use the transform here, not the fit transform, because I have already fitted the data. Okay, so, and this will also map the values. This will make our data ambiguous, because maybe first time fit transform is mapping no to 0 and y to 1, but if I use the fit transform again for the test data, maybe it map no to 1 and y to 0. So that's why I'm using the transform here. So that's how, like, what we generally do, and this is what you have to follow. Now if I run it, it is transforming the data. Here you can see the cell is executing. And okay, let's wait until it executed. Okay, my browser is, let me reload this tab first. Okay, I got some error. So let me run all those ones to make sure of my data. Yeah, so now okay, this is encoding. So I'll get, I guess I might get some error because of the values we have in date time, because in test data we might have some other values compared to the uh, training data. um, okay, okay, so I got this value error which is showing found unknown categories. Okay, this is a lot. What I can do is, there is a option, like there is a parameter in uh, ordinal encoder which is, okay, yeah, here is, yeah, unknown value. So these are the parameters, handle unknown, which basically we got some unknown values here in our test data. uh, like here you can see encoder dot transform test data test gf. So in our test data we got some unknown values. We basically, what we do is, we set them to -1, okay, and rest, for the rest of the values we use the encoded values. So the values which are not mapped, we got some new values which are not mapped, so that's why it is giving me error. If I use this, like these two parameters, it basically, this handle unknown which will tell us that only use the encoded values, and for the unknown values it will interpret them as -1. Okay, now if I run this, this will run successfully, and yes, now it has run. If I do x dot head now here you can see my date time is converted to some integer column, my store and forward flag is converted to 0 and 1, and pickup date also, and the pickup time also. Now let's just like check this store and forward flag value counts. Here you can see my all the no's are converted to 0 and while yes to converted to 1. Okay, so this is what ordinal encoder we do. uh, so this is just a one way of encoding the values. There are obviously some other ways also. It's like, due to the time constraint, I am not doing a lot of things right now. Like we have done basically like all these 4 steps. Like today I am not using this 5th step, which is feature scaling. I will use it in the further sessions as we go ahead. Then in the 6th step we have to select useful features. So there are various ways to use, like to select useful features. Okay, but currently I am not selecting any kind of useful features as of now. uh, what I am doing is like, uh, okay, I'll just select all the columns. So these are like all the columns I have. Like if I write x dot calls, so I'm selecting all the columns, so I don't need to do any kind of step right now. So I'll just ignore this step also. Now if I go back, I have now this modeling. So in modeling, as this is a, like we have to predict a continuous variable which is the time trip duration. So what we will do is, we will use like linear regression today. Okay, we will use two, okay, let's use only one model today, which is linear regression. And how to use it, we'll do from sklearn dot linear model, and then import linear. Okay, it automatically came. So this is linear regression. So now if I run it, the cell is run. Now I'll write it here, modeling. Okay, now I'll create my model, which is linear regression. So linear regression, and I just have to call this. So now my model will be created. Now to train our model, basically to fit our data into the model, to train the model, what we will do is, we will write model dot fit, not dot train. We will write model dot fit, and then we will pass on our data x, and then we will pass on y. So this is how the model will be trained. Now if I run this, model will be trained, and it is trained very fast. like so yes, now our data is fitted into the model and our model is trained. Now like in linear regression, as I said earlier, like we have weights and bias, right? We have slope and as well as the intercept, so we can get those values also. So if I write model dot intercept, okay, okay, not the intercept, I guess intercept, yeah. So this is my intercept, if you can see here. Similarly I can get the weights also. Model get, I guess get params is a function, okay, not the get params, uh, mm, coefficient, yeah, sorry, coefficient. So coef, this is the these are the weights of the, like you can see, okay, let me drag it here. Weights of linear regression, and each weight correspond to each function, okay, oh sorry, each feature. So like if I check the length of these coefficients, and if I check the length of my like x dot columns, this will be same. Why? Because each weight, like each of this value is corresponding to my each of the column, okay. And after that what is like mainly happening, it is like in linear regression, okay, let me just create another cell here. Linear regression we are using, and we have this equation. Don't just, like, you can ignore the syntax as of now. So f of x, and we have w x plus b, okay. So this is the equation we have where let me write it. uh, w are the weights, or we can say coefficients, and then b is the bias, or we can say intercept, okay, and of course x is the data. So this is what we are doing, and we are getting like the value y, we can also write it here, which is the predicted value, like so y, which will be the predicted value. So currently the model is fitted, okay, so obviously we won't get any kind of predictions. But now like, okay, let's get into our steps first. So we have like this model tuning and validation, we will do this in further steps. Now last is submitting predictions, so let's get into that, like 9 submitting predictions. Before that, like, okay, in that only I'll do this. So in test gf.head, if you see, we have these like vendor id, pickup date, time, passenger count, and a lot of these things, okay. uh, what I'll do is, let's take this first row only. So I'll write test gf dot ilog and 0, okay, and colon, or normally 0 if I do. So this is my first like this is my first row of the test data frame. I have to predict the duration of this strip, okay. This is my first strip, and what I will do is I'll just write model dot predict, and there I'll pass my data, which is this. I'm only doing the prediction for the first row only. So I'll get, okay, reshape your data okay. So it is containing a single sample, that's why it is saying so. uh, yeah, okay, okay, yeah. In series we don't have, so let's take, let's say uh, let's take first 5, yeah, let's take first 5 rows only. So I'm not doing the reshaping and all right now. So what I'll do is I'll just use this, and here you can see I got these values. So this is the prediction of my model for these first 5 trips. For the first trip, this is the prediction for 40 seconds, and the for second it is 132, and then 473, then 780, then 532. So this is the prediction. Okay, so these are the predictions, and now like I have to do for all the test data. So what I'll do is I'll write uh, what I can, yeah, test spreads. So test spreads, I'll assign the variable, then I'll do model dot predict, and I will write the complete test here. And let's see the test spreads also, how it will look. So here you can see this is my model has predicted all the values in the test GF, and this is my test predictions. Okay, so obviously like there is a way to do the submission in the competition. So like if I check my sample submission, so pd dot read csv, so this is my sample submission. Like I have 2 columns. Okay, currently my predictions are in just a numpy array. If I check the type of this test spreads, so it is a numpy array. Okay, nd array, and like an array can be of any dimension, so by default the type is nd array. So this is a numpy array as of now. I have to convert these predictions to a data frame, which will have the corresponding id of each test data frame like this, and uh, and the trip duration, corresponding trip duration in seconds. And also like you can see these are in the integers, not in the float. So here I'm getting the floats. So what I can do is I can simply write as type, and let's say np dot int 16 will be good, I guess. Yeah, let's like just to be safe, we will use 32. So now I'm getting all these values as in integer values. Okay, now what I will do is I have to make the summation in this manner. I'll create my data frame, so I can write it as output pd dot data frame, and in this I will pass a dictionary. What this dictionary will be, okay, I am passing a dictionary in it. Like this is the dictionary format. In this dictionary, first I have the id column, then I have this trip duration column. I'll write both of these columns here, and in the id I must have all the indexes. So what I can do is I can basically use the test gf dot index to get the indexes. Like if I do test df dot index, I'll get all the indexes. Okay, so I'll just simply write test df dot index here, and my test spreads here. So these are the predictions of my test data, and this is the index. So there is a way to do the summation, so that's why like we are doing in this way. Now this is my output. If I write output dot, okay, now I'll just simply run this output. Okay, I am getting it. Yeah, I have forgot a comma because we have two key value pairs. So if I run it, and if I check my data, like the output here, you can see this is now in the same format as in the sample submission .csv file. Okay, so do you guys have any doubt what I have just done, like till the from the feature engineering?
No, no, no doubt. No.
Okay, is it clear to you all? You can just give a thumbs up.
Yes.
Okay, great. So uh, like what we did is we, okay, before doing that, yeah, so the last step now, one thing which is left, which is to do the, like we have to submit the predictions. Okay, how to submit it? We have to create a submission csv file. How to do that? As I have told in my second session, we will just use .to csv function. The submission will be in the csv format, so that's why I'm using to csv function, and I just write submission.csv, and I also write index equals false. Why? Because I don't want this 0 1 2 3 4 index. I'll just need these two columns only. Okay, now if I run this cell, uh, here like in the output, you will see the memory increases. Okay, earlier it was 10 point some MB and now it is 18 MB, so 8 MB file, I guess the submission.csv is of 8 MB. So this is the submission.csv. Here you can see this is of 8.8 MB, and I can either download it from here also, like if I want. Okay, and let me just download it in my downloads folder. Yeah, so this is how we can do the summation. Now let me generally, like, okay, uh, so this is like what we do normally. And how we can save the notebook, we can simply like click on this save version, and we can either give a name like simple ml workflow. If I just give it a name, simple ml workflow, and I can click on save, then my notebook will be saved. Okay, so yeah. And normally, like, uh, in the competition, what you will do is, okay, so this is the competition, right? Now what I'll do is I'll just go to my submission funds. I don't have any submission right now, this is my first submission. I'll click on late submission. I can either like submit my notebook, or I can either like upload the file directly. Okay, uh, but like in the MLB project, you have to do the note, you have to submit the notebook. I'm not submitting the notebook right now, I'm just submitting the file. I can just directly like either like drag and drop my file here, or I can browse the file. I'll click on browse file and go to downloads and select the submission.csv and open. Yeah, so it is getting uploaded, and I can also provide some description. It is optional. I can just write simple ml workflow with linear regression. Okay, now I am clicking on submit button, and it will submit my uh, like submission.csv file. So it is submitting, and it said success. Now okay, here you can see I get the score also. This is like 0.81 score. Like the score which is being calculated, it is calculated like root mean squared logarithmic error. You can ignore just as of now. Okay, logarithmic error, so I guess the range is maybe 1, like from 0 to 1. Now if I go to leaderboard, here you will see like I have a submission, your recent submission, and my score is this is like my public score, this is my private score. So like there are two types of score normally. The private scores is like the number of decimal show. Okay, so the public score is basically which is shown normally to like everyone, and the public score, like jab tak aap, till the competition is running, only the public score is visible to everybody. Okay, when the competition ends, a private score will be calculated. Public score is generally calculated based on the 20% of our submission file, and the rest of like when the competition ends, on the rest 80% of our submission file, uh, like the score will be calculated, and that will be shown as a private score, and that is the final score. Okay, now if I go to like click on this, jump to your leaderboard position. Okay, it is okay, it is not taking me to the position, I don't know why. Okay, so let me like go by myself, like scroll. Okay, so my score is, yeah, public, I guess here. Okay, my score is, I guess, way higher, like way lesser compared to this. Like here you can see the score is 0.2, 0.3, and 0 point, like something like this. So the lesser the score, the better it will be, because they are using this formula to calculate. Okay, so there are many formulas we will discuss in further sessions, and my score is this. Obviously this is worse, this is not the good score, but like in today's session I just want to give you an overview, like how to do all the stuff. And of course we will improve the score day by day, like when we do more we will do more EDF, we will do more feature engineering, and a lot of stuff. Okay, So like in today's session, like we mostly gone through the basic ML workflow. First we have discussed about the like what is the like x and y features, what is the predicted label, target label, and then we did some EDA, and then we basically did some feature engineering. We created some new features, and after that we converted those features to numerical values, the categorical features, using ordinal encoder. Okay, and after that we did like we created a model which is linear regression model, and we fitted the model. And this is after that we have did the predictions, and this is like the model dot predict. Using model dot predict function, we have done the predictions, and we have submitted those predictions into the competition. So yes, this is what today we have done. So is this all the things clear to you all?
Yes.
Okay, do you guys have any doubt?
हेलो।
Yes.
आप जो अभी बताएं उसका यूज कहाँ होगा? वीक 2 में तो ये सब का यूज नहीं था, सिर्फ बेसिक सा यूज था।
Okay, like in week 2 they told us about various scikit-learn APIs, right? Data sets, pre-processing, and linear model, and other things, right?
हम्म,
हाँ, so उनका भी यूज़ इसी में ही है, like to create the model, to understand the data, to analyze the data, to make our data ready for the model, to create the model, do the predictions. Okay, like in further weeks when you go, you have to do this thing only, you have to do the predictions. Okay, also like in MLP project, this is the thing mainly which we have to do. We have given some data, and we have to do the ED and all this stuff, and based on this stuff we have to do some predictions, and that submission we have to, that predictions we have to submit. So like they just give a they gave a overview of the scikit-learn library in week 2, and but like in further sessions, like in further weeks, they will tell in detail about algorithms also, like machine learning algorithms, and the same thing which I will do in the next session. uh, like in that I will like tell you about the complete algorithms from scratch, like linear regression, SVM, logistic regression, decision trees, random forest, and all, which we basically which we learned them in MLT, right? We learned about perceptron, and linear regression, SVM, support vector machines, and PCA algorithm, and a lot of these. So we will do all these things in detail. अभी मैंने आपको एक जनरल ओवरव्यू दिया कि लाइक हाउ टू डू द ML मशीन लर्निंग हम कैसे करते हैं. ओके,
और इसका प्रैक्टिस कहाँ कर सकते हैं?
या ओके, फॉर द प्रैक्टिस व्हाट यू कैन डू इज okay, you can simply go to this kaggle.com/competitions, या kaggle.com पे जाके click on competitions, click on getting started. Okay, and then you
ओके,
will get some these competition. You can just choose this one, house prices or Titanic. Like from the first day you can choose any of these, because these are the basic and these are very best for the beginners. कंपटीशन पे क्लिक करना, क्लिक ऑन ज्वाइन कंपटीशन, कंपटीशन ज्वाइन करके आपको डेटा दिख जाएगा. ठीक है, देयर यू
ओके,
विल गेट द डेटा, एंड फिर आप लाइक इफ आई क्लिक ऑन हेयर राइट नाउ, I understand and accept. So if I reload it once, so here now like you can see I can see the data. So just click on submit prediction and notebook, and create notebook, and notebook create करोगे, and उसके अंदर you have to do all this stuff, like you have to do the EDA, you have to do the feature engineering, feature scaling, and transform these features to numerical values, and then you have to create the model. Okay, after
ओके,
creating the model you have to do the predictions on the test data. जो टेस्ट डेटा यहाँ पे दिए हुए ना, test.csv, हमें इस पे
हाँ,
प्रिडिक्शंस करनी है. वी हैव टू डू द प्रिडिक्शंस एंड वो प्रिडिक्ट करके हमें जो है सबमिट प्रिडिक्शंस पे क्लिक करके वी हैव टू सबमिट दोज प्रिडिक्शंस एंड उससे वी विल गेट like some score in the leaderboard and we have to improve that score as much as possible. Okay, so the
Okay.
score will be calculated based on the provided formula they have given. So here they have given the metric for the evaluation, like in the overview you can see the formula based on which they are calculating the score. This is the formula which they are using, which is root mean squared error. So हमने मीन स्क्वायर एरर पढ़ा था राइट इन एम एल टी, लाइक
हाँ, हाँ।
except the under root you can see this is the same thing, right? uh,
हुँ,
Difference between the actual and the predicted value, and we will square them and we will find the average of it, like we will divide by the number of samples, then we will get the mean square error, right?
राइट।
And we will just take out the root of it, of the mean square error, MSC, and that is the root mean square error. And this house prices competition is using RMSC as the metric, and based on the root mean square error you will get some score, and this you can see on the leaderboard. And आपको फिर like you have to improve that score. So here you can see कुछ लोगों का स्कोर बिल्कुल, एक का स्कोर तो बिल्कुल ज़ीरो गया. सो बाय दिस यू कैन सी कि उन्होंने लाइक कैसे प्रिडिक्शंस करी होंगी, लाइक उनकी प्रिडिक्शंस 100% एक्यूरेट होगी, दैट्स वाई दे गेट द स्कोर एज ज़ीरो. ओके, like the score can be varies based on the metric. So in the root mean, in the regression task generally हमें जो है हमारा स्कोर कम से कम करना होता है. ओके, so like in
ओके,
this New York City taxi prediction I got this score as 0.81, so I have to improve it until I get the score in range, let's say from 0.28 or 0.30. so you can see अभी मेरा स्कोर काफ़ी वर्स है, right? It is not good.
ओके,
So we have to improve it. And how can we improve it? We can do more data analysis, we can use different models, we can do feature engineering, we can apply like different MLP techniques.
ओके,
So yes, this is all
अ,
we have to do.
ओके, थैंक यू।
Welcome. um, Before June 23 we need to share only username. uh, Yeah, right now they won't check the cutoff. Not before 23, I guess before 20 you have to submit your username and notebook, I think. I'm not sure, but 20 भी एक deadline है, so आप एक बार ही check कर लेना. Okay. Cutoff they will, of course they will check the cutoff and you will get some form or some sheet in the project guide only, where we can see like where we stand and is our ID registered in their database or not. Okay, so किसी को कोई doubt? Yes, they mentioned the cutoff as 0.8. You can submit before June 20, but deadline is 20th June, I guess. For one assignment the deadline is 20th June, and for one I guess it is 21 or 23, I'm not sure, but yes, 20 is yes. For crossing the cutoff, no, for crossing the cutoff there is no such deadline, but of course you have to do before, like uh, you have to do the stuff before all the viva deadlines are end, like so that you can have a viva, right? Either like else your project will be discarded. Yeah. So do you guys have any other doubt? um okay, so welcome. And like in today's session we have gone through this competition. Okay, but in next session I'll try to use some other data set also, uh, जिसमें आप लोग भी प्रैक्टिस कर पाओ. ओके, सो जैसे लेट्स से हाउस प्राइजेस और समथिंग एल्स, so just say we all can practice together. Yeah, of course we will do the ADA, and like as you said in week 2 they have discussed about a lot of like the sklearn libraries and all. They just gave an overview. हमें जो है मेनली वो सारे पूरा लाइक सबका एक एक नेम याद रखने की ज़रूरत नहीं, हमें बस पता होना चाहिए कि लाइक अगर हमें डेटा को इनकोड करना है फ्रॉम कैटेगोरिकल टू न्यूमेरिकल हमें वो प्री प्रोसेसिंग लाइब्रेरी में मिलेगा, API में मिलेगा इन scikit-learn। एंड हमें अगर लीनियर मॉडल चाहिए लाइक लीनियर रिग्रेशन, तो हमें लीनियर मॉडल में मिलेगा। बस हमें इतना पता होना चाहिए, एंड उसका लाइक कोई रट्टाफिकेशन नहीं है। वी कैन बेसिकली गेट दिस बाय जस्ट ओनली प्रैक्टिस। ओके, yes, of course I will share the notebook. I will run the notebook, add some documentation also, and I will share it in the YouTube my video description. Okay, in next session we will do a lot of EDA in a new dataset. uh, Welcome. And of course, like, we will do a lot of feature engineering stuff which is in the week 3, and of course it will be helpful for the MLP project. So yes, that's it for the today's session. I hope आपको अच्छा लगा होगा।